All right, so we're going to move on to the third set in this particular mock. And in my opinion, this is probably the second easier set. Not very difficult. You have to be slightly careful. 1 point if you get, you'll be probably getting the entire 5 questions. So this is one of the questions, or rather one of the sets that you should have attempted. And probably even 12 to 15 minutes is a good time to spend on this, although it will not take you that long. The set, if done correctly, will be solved in under 10 minutes. Let's see what the question talks about. So there are 4 people: Saral, Tarun, Nitish, Aditya. So we have S, T, N, and A who are playing a card game. Initially, 44 cards are distributed equally, which means 11 per person. These 44 cards have 22 pairs, such that a pair consists of 2 identical cards. The cards in each pair are different from every other pair. So this is not the typical playing cards. This is a special set of cards where there are 22 pairs. Each pair will have 2 cards which are identical, and there are 22 distinct such pairs, right? So making up 44 cards. Finally, one extra single card different from all the 44 was distributed. So one extra card is given. It is not mentioned who got that extra card. Okay. After that, each person was asked to remove the identical pair of cards from their set. So basically what it means is, if you have 11 cards, you'll start taking out the identical cards if you have. If you don't have a pair, you'll keep it as it is. So any number of cards could be taken out depending upon how many pairs you have got in the random distribution. Now, after the removal of pairs, 11 cards were left in total. So all of them put together, they have a total of 11 cards. Now these 11 cards are taken and redistributed. So they are shuffled and redistributed among them. At this time, it was found that the number of cards with Saral, Tarun, Nitish and Aditya were in descending order. So basically Saral greater than T greater than N greater than A, and the total should be equal to the sum 11. Okay, this should be the total. So first of all, let's look at what could be the distribution. So if I start with the minimum most for A, 1, 2, 3 and 4, the total is 4, 5, 6, 7, 8, 9 and 10. But I want my total as 11. The only single way in which this is possible is when Saral has 5. So descending order distinct number 11 total, that is only possible if it is 5, 3, 2, 1. There is no other possibility. This is the first thing. Okay. Also no one had a pair of identical cards. So basically all these. So these 5 are all different. These 3 are different. These 2 are different. This one is different. But if you combine them all 11, what will you get? You will actually get 5 pairs plus 1 extra card. This is that 1 extra card. So totally see, all the cards should be in pairs. So out of the 22 pairs, 17 pairs have been taken out. Okay. So you are left with 5 pairs. But they are given in such a way that you can't take them out in a single person. So they are distributed among the 5 people along with that extra 1 card. Okay. Also, one pair of friends had the maximum number of identical card pairs, and no other pair of friends had as many identical card pairs among their cards. So basically there is only one pair of friends having the maximum number of identical card pairs among their cards, and no other pair of friends had as many identical card pairs among their. So basically the maximum number of identical any pair you take, the maximum number of pairs you can get is only for one group of 2 people. So what I mean to say, or what this means is, let us say you take S and T. If S and T together have 2 pairs, of cards, then nobody else can have equal to 2 or more than 2 pairs. So everybody else together should have less than 1 pair or equal to 1 pair. Basically 1 pair. That's the whole idea. Okay. Now these are the questions. Who doesn't have the single card? For sure. So now let's try to understand what are the various ways, what are the various possibilities that are happening here. So I will start with the first question here. So I have S, T, N and A. So 5, 3, 2 and 1. Let me call the cards as A, this is one pair, B, B, C, C, D, D, E, E and finally one single card F. Okay, I will look at the cases. First case number 1. Let us say the F card is here. F card is with A. One card that is taken care of. Now, what could be the 5 cards with S? The only way in which there can be 5 cards here with S is A, B, C, D, E because nothing can be common among S. Now for T and N, it doesn't matter which 3 cards you put. You have to put 3 cards, A, B, C. Doesn't matter, A, B, C, B, C, D, whatever. 3 cards you put doesn't really matter. But there should not be anything common within within T. So A, B, C and then D and E. So this is case number 1. This is possible. Okay, this is one case. Let's look at another case. Now what happens if I get F in the set of N? This card, single card is with N. Then again I will have A, B, C, D, E. Then I have A, B, C, D here and E here. Now again, please don't worry which is A. See, this is A, B, C, D is definite. Now you don't have to worry whether A is coming here, B is coming here or C is coming here. The point is these 3 are distinct. The logic will remain the same as long as they are distinct. Okay, this is case number 2. Now let's look at case number 3. What happens if F is coming here? Then again I have A, B, C, D, E. Then A here and B here. Then C, D and then E. Now there's a problem in this arrangement. What is the problem here? Now look at S and T. How many common pairs are there? You have A common and B common. So 2 pairs. Okay. Look at T and N. You have 0 common pairs. Okay. Look at C and D. Sorry, N and A. You have 0 common pairs. So N and A there is 0 common pairs. Between T and N there is 0 common pairs. Then between S and T there are 2 common pairs. Okay. So as of now the highest common pairs is 2 and only one pair of S and T should have this. No other pair of 2 people should have 2 pairs matching. But if you look at S and N, C is common and D is also common. So again you'll get 2 here. So the highest, which is 2, is happening twice. One of the statements says the maximum number of pairs between 2 people is there only with one group of 2 people or one pair of 2 people. It is not repeating again. That's why this case is not possible. Then again, let's continue. S, T, N, A. I will look at case number 4. Case number 4, this time, now I have taken F with the other 3 people, T, N and A. I have looked at all possible cases. Now I will look at F coming here. If F is coming here, then I'll put A, B, C, D. Okay. Now my issue is there are 2 E's. Where will the E's go? Obviously both E's cannot go to the same person. So because of that E's, I will have 3 cases here. Case 5 and case 6. What are these case 6? So both of this will have F, A, B, C, D. Similarly, this will also have F, A, B, C, D. But in one case, I'll take E and E like this. The other case, I'll take E and E like this. And the third case, I'll take E and E like this. So then I'll have A, B, C, D. Okay, then I'll have A, B, C, D. And E is taken care, that is done. And then I'll have A, B, C, D, and then E. And here, in all these cases, we'll have to check whether maximum possible number of commons are there with only one pair of people or more than one pair of people. So here you can see maximum is 3 and you take any 2, 3 will not come again. Here also maximum is 3. You take any 2, 3 will not come again. Here the maximum is 2. Okay, the maximum is 2 and if you look at any other two people, you will not get 2 again. Why? Look at these two. What is the common here? 0. There is only 1. Look at these two. There is 0. Actually, no common. Look at these two here. There is only C, one which is common. And any other thing like this, you will see that 2 is still the highest. Similarly, if you look at these two people, 2 is the highest and nobody else will give you 2. Here also 2 is the highest. Nobody else. Okay, here I think this will be giving you 2. So this case is not possible. This case is not possible. So we got totally how many cases? Case number 1, case number 2, case number 4 and case number 5. 4 cases that are totally possible. So this is the entire solution. Now we can solve the entire set of questions. Who doesn't have the single card for sure? Now F can go to A. So A is not your answer. F can go to N. So N is not your answer. F can go to S also. So Saral is not your answer. So who did not get your card F? Only Tarun. So Tarun is definitely your answer. Next question. If Tarun and Nitish have a pair of identical cards, then who has the single card? T and N have a pair of identical cards. So let's take a look at T and N. T and N have a pair of identical cards. Okay, sorry. Yeah, T and N have a pair of identical cards. This is the scenario. Okay, nowhere else T and N. Is there any other way? T and N having identical cards? Nowhere else. Yes. So this is the only case. In that case, what are they saying? Then who has a single card? The single card is there with Saral. Obviously, this is the case of F being with S. So the answer there is Saral. The first answer is what is the first answer? It is Tarun. The second answer is Saral. Third answer. How many of the following can be the number of pairs of identical cards with Saral and Tarun? So Saral and Tarun, what are the possibilities? Let's take a look at S and T. S and T 3 is possible. S and T 3 is possible. S and T 2 is also possible. So 3 and 2 both are possible, right? So let's take a look at 3 is possible. Yes, and 2 is possible. So how many of the following can be the number of pairs of identical cards with Saral and Tarun? 2 of them are possible. So that is option B. 2 of them are possible. Okay. Now the fourth question. If Saral has the single card, then which of the following is definitely true? So Saral has a single card. So we are looking at which possible case? We are looking at case number 4 and case number 5. Saral has a single card. Okay. Now let's look at the options. N and A. N and A do not have a pair of identical cards. So is it possible N and A do not have a pair of identical cards? Nor N and A. Is it possible? No, it is not necessarily true. We can see here E and E are there. So N, remember this is N and this is A. So N and A can have a pair of cards. So first one is definitely not true. Okay. Second one, Tarun and Nitish must have a pair of identical cards. So Tarun and Nitish must have a pair of identical cards. T and N may or may not be possible. So here it is true. Here if you notice, it is not true. Okay. So it may be possible, it may not be possible. So it is again not 100% true. A maximum of 2 pairs of identical cards are there between any 2 people. So let's look at the maximum common pairs. So if you look at maximum, the maximum is 2 between any 2. Is it okay? In fact, this is not 2. This is 3. My bad. This is 3. A, B, C. So this is 3. And you can have here in this case it is 2. So the maximum is not 2. The maximum is 3. Okay. So this is also not correct. So therefore, this has to be true. But anyway, let's verify. Saral and Nitish, S and N must have a pair of identical cards. So S and N must have a pair of identical cards. So you can see C is here, C is here. In the case number 4, yes, one of them is identical. In the case number 5 also, one of them is identical, D and D. So in whichever case you take, one pair of cards is definitely true. Therefore, in that particular question, option 4, D is correct. Last question. How many of the following numbers can represent the number of pairs of people who don't have any pair of identical cards with them? So we are looking at not having identical cards. So let's look at case number 1. Now S and T, ST have identical cards. So this is not your group pair. SN is also not your pair. And SA, so SA is one pair here. Okay. Because between S and A there is nothing common. Then TN is one pair where nothing is common, and TA is one pair where nothing is common, and NA. So in the case 1 there are totally 4 such pairs where nothing is common. Let's look at case number 2. ST, enough common things. S and N, D is common, so that is not going to be counted. S and A, so SA is counted because nothing is common. Then TN will be counted, and TA will be counted. Okay, TA is also nothing common, and NA again 4. So this is also 4. Okay. Now let's look at case number 4. If you look at case number 4, ST they have common, SN also has common, SA also has common. TN does not, TN has a common, so this will also not be counted. TA does not have anything common. NA does not have anything common. So TA and NA don't have anything common. So there are 2. So the non-common pairs can be 2 or 4. Let's also look at another last final case. Now in this case again, ST has common, SN has common, SA does not have common. Okay, then TN does not have any common, TA does not have anything common, but NA, you can see E and E, they are common. So in this case there are 3 of them which are not having anything common. So 2 is possible, 3 is possible, 4 is also possible. So we can have the possibility of 2, 3 and 4. So out of these 4 options, 3 of them are possible. Hence option C. So this set, if you are careful, you could have got at least 3 questions to 4 questions correct. It should have been attempted in the exam.